Welcome to RFormula. After completing this lesson, you should be able to understand why RFormula exists, understand RFormula notation, understand the transformations RFormula produces on linear models, and use RFormula on a real-world example. In modelling, we often define a variable as a function of other variables, or predictors. The pseudocode for this is very close to more traditional math notation. It could be that a variable y equals the combination of several other variables, variable a and b, all the way to variable z. The problem is, it isn't entirely accurate to use the equal symbol because we are generally working with variables that are random, and it really only makes sense for two random variables to be equal in distribution. So we use the tilde sign to denote that one variable is composed of others, i.e. that one variable will have the distributional qualities of the particular composition of the others. The add symbol represents the inclusion of a variable in our model. This table shows some of the ways variables can be combined in R. The interaction term is used when the combination of two or more variables contribute to the outcome of a third. For example, the joint effect of inhaling asbestos and smoking is higher than the sum of both of those effects separately. In R, we don't tend to go down to the abstraction level, so we aren't concerned much with the internals of the system, unlike with Spark. An example is that the string input columns in R will automatically be one-hot encoded. Note how Spark actually fits two models for the two levels of the categorical variables that are one-hot encoded. When we are dealing with multiple categorical variables, what Spark is doing is to fit multiple models, one for each condition. This is the same dataset we downloaded in the lesson on using principal components analysis for feature engineering. First, we use the :dp to add the dependency for the Spark CSV library so we can use it. We then create the SQL context so we can access data frames and import the implicits required for automatic data type conversions when we load the data. We then read the CSV data as we did in earlier lessons, specifying the format, the delimiter character, whether or not there is a header row, and whether or not to infer the schema. We will use the crimes2 data frame from the previous lesson, 3.3.4, Principal Component Analysis for Feature Engineering. If you arrived at this video without viewing that one first, you may want to go back and do so before viewing this one. We provide the formula as to how to calculate what we want from each field and provide the features and label column names. Next, we fit the formula and transform the results. When we select the data by column name, here are the results. So what we've seen is that RFormula is a very handy shorthand to write quite elaborate models. It started in the R world used only on linear models, but over time, other models, for example random forests, started using formula notation to specify models. RFormula simplifies the creation of machine learning pipelines by providing a concise way of expressing complex feature transformations. Having completed this lesson, we should now be able to understand the RFormula interface to model fitting and fit a model using the formula interface.